You're going to want to listen carefully to the directions, okay? Do you guys figure out a straight edge? Something that you can use? Whether it's a ruler, whether it's an ID card, whether it's the edge of someone's calculator that's nice and flat, whether it's the edge of someone's composition book, that could totally work. Okay. That's just something to strategize first. So the tangent line problem. In the summer review packet, do you guys remember how the tangent line was illustrated? I mentioned it the other day. It's been 2 days, though, or it's been a weekend. There was a question at the very end talking about the derivative and being a slope of a tangent line. And it was like, this is how you can think about a tangent line. It's like a pencil hitting up against a curve. It's like a pencil hitting up against a curve, right? So question, what would the slope be of the tangent line at the vertex of any parabola? If it's just the pencil up against the curve, what would the slope be of the tangent line at a vertex? Because what's the pencil? Wait, so what are all the slopes? What's the sign of all the slopes? Negative. A vertex that's rounded, where a function is going to be positive. Now, this isn't. Give me any function you want, and get the graph of it for you without a calculator. Mind blown. But we're going to use stuff like this where we can figure out where the derivatives are negative or 0 or positive to think about decreasing and increase, and then we have to think about like concavity. Very negative to less negative. For increasing or decreasing has to do with concavity. There's all these tricks. That's not right. But if the pencil is a good illustration of a tangent line against a curve, I want you guys to think of that as we do an exploration where we actually say, okay, hold on, pause. So the tangent line is what we're supposed to be getting to. But with pre-cal or even anything pre-cal, before calculus, anything before calculus, before derivatives, before limits, the only way that we could find slopes was between 2 points. Okay. So you can see on your teal graph, you actually have the graph of, and I'm sorry some of them got cut off, it's y equals x squared. Okay? So you have a graph of y equals x squared zoomed in around the point 0, 0, and 1, 1. You guys see the little 1 and the little 1? So you have the 1, 1 and the 0, 0. You have the graph of y equals x squared super zoomed in. Okay? Telling us that these lie on the graph Q1, Q2, Q3, Q4, Q5. Each successive point gets closer. For instance, hold on, pause. Where is this point? Point 4. Okay, I want someone to take charge of the expo marker really quickly. And what's a good way of approximating where point 4 is? Why don't you go by tenths real quick? What's an easy way to go by tenths? Go in half. That'd be 0.5, right? And then you can go ahead and fit in. If you want to, you can go a half again, but that'd be 2.5. Do a little 0.2 before, 0.3 after. Go ahead and put your 1 into tenths. Go ahead and try to put your 1 into tenths. It's going to be a bit approximate. It's really easy to erase. If you cut it in half, then you just need to fit in 5 here and 5 here, or I guess technically fit in 4 tick marks and 4 tick marks. You guys cut it into tenths? So like a 0.1, 0.2, 0.3. Doesn't have to be perfect, but approximate. Okay? Now go find the 0.4 and label him for me. So cut your 1 unit into tenths. Go find the 0.4 and label it for me. So hopefully you should have something like okay. And you had your 0.1, sorry, your 1. That's the 0.11. And then you were supposed to, that wasn't very even. That's really rough. Okay, what would the point be at 0.4? Because here it says 0.4 f of 1.5. What's going on there? You could go ahead and plug in 1.5 squared because f of, you're squaring the unit. Now here's the weird thing. Is this technically correct? If your x is 0.4, should your y be f of 1.5? Does that make sense? Which ones do make sense? Right? These ones make sense because the x goes with the y, the x goes with the y. I was trying to go to 0.4. What mistake did I make? What else should I have changed? If 0.4 is what I was going for, I can't just change the x. What else do I have to change? So let's change these really quickly. The 0.4 needs to change, but what else needs to change? Who else doesn't belong? Which of these is not like the other? He doesn't belong either, right? Okay, so how do we find the y value for 0.4? 1.5 doesn't make sense. I'm at 0.4, right? Plug what in? Good, plug in the 0.4. Why do you have a calculator? Because I'm being nice. So 1.5 doesn't make sense, but 0.4 makes sense if my function is y equals x squared. Now, some of you should do this one just in your head, but some ones are going to be a bit messier. If you square 0.4, what are you going to end up with? 0.16. This is your Q1. Does that make sense? Okay, but what other points do you have? You also have 0.99. How are you going to approximate that one on the graph? I'm just going right now from below. Get really close. We're going to go over here to the 0.9, then we're going to get really, really close to the 1, right? So then we're going to say something like, right there maybe? And then we can go ahead and put 0.99. How are you going to find the y value? Square that, right? So it's going to be f of 0.99. This is going to be Q4. But what other points do you have? Those ones were coming from the left of 1, but what are all these other ones? Coming from the right of 1. So what are you going to have to do on the other side of 1, my people that were making my units? Aren't you going to have to go one more? So then you have 1.1. Then we had right here 0.99. And what's the struggle? 1.1 I can mark a point on, right? And I can go ahead and do that. How am I going to do 1.01? How am I going to do 1.000001? Get even closer to that. So it's going to get a little bit interesting as far as you guys trying to approximate. But what are you supposed to be doing with every single one of these points? Let me use the one example that I have over here. The one example that I started with was Q1. Group exploration says to go ahead and do what we would call a secant line. And if you wanted to, you could even color code it. Not that you necessarily need to, but you can come up and get some other markers if you want. But what I want you to do, once you figure out the x different points that I've given you, and once you've found them approximately on together, using, wait, what formula are we going to use in order to get the slope between these points? y2 minus y1 over x minus x. Oh, I don't want to move that. Oh, there he goes. Does that look about parallel to those two? There we go. Once you find the slope, you're going to go ahead and connect. That's rough. I'm going to orient my board once you guys get started, but you're going to connect and then you're going to go ahead and do the slope. So help me out real quick. Thomas said that the formula for slope was m equals y2 minus y1 over 2 minus x1. So how are we going to find the slope between these two? Between the point 1,1 and the point 0.4 and 0.16. Now, would you necessarily want all of that in the graph itself? No. So maybe that could be something that you do use your spiral and your bell work for, or you could just have some different people set up and do that work. But yeah, you would go ahead and do 1 minus 0.16, then you would have 1 minus 0.4. Can anyone throw that in their calculator really quickly, either using the cool nifty fraction feature or using parentheses and divisions? What do you get? 0.84? Perfect. Uh-oh, 0.6 and 0.84. I'm hearing different answers. What's the M? All put together. Okay. What do I want? At the end of the day, I want every single point drawn. I want every single slope of each secant line that's drawn figured out. And I want you guys to try to put it all together to see if you can figure out what the tangent line slope would be. So you're going to graph the secant lines. You're going to find each of the slopes between each of these points and the point of tangent C1, 1. And then you're going to take all the information, whether coming from below or coming from above limits, and see if you can figure out what would be the slope of the tangent line at the original point that we were talking about, which is 1, 1. Ready, set, go. Ready, set, go. Whoever had the expo, you get to hand it off to someone else, unless they are very, very, very artistically challenged. But otherwise, it's their turn. You were already working. Let me put the directions up so you guys can read it. There you go. Everybody can be helping. Someone can be calculating. Someone could be drawing. Someone can be finding the y values because you're going to need x's and y's for each of the points. So at the end of the day, you should have 5 lines. With 5 slopes. Could solve by hand multiple points, getting closer and closer to the point of tangency and doing this word approach. And you could think about, what would pause the limit as the points get closer? Change in x's seem to be 2. And what is 2? The slope of the tangent line. The slope of the tangent line is the derivative. Okay, we'll put it all together in group exploration number 2 tomorrow. If you guys want, you can copy it into your notes. I'll take